Alrighty, so wasn't feeling well last night when I first tried this and kind of gave up after 50 minutes and went back this morning to do it um, after feeling a little better. And I went ahead and just tried it offline. So anyways, this problem is making a binary string that is of zeros and ones. Um, Using two operations to make it alternating. So alternating being either like 10 10 10 until the end, or 0 1 0 1 0 1 to the end. So the operations that you can perform to change this binary string to that alternating form is you can remove, or the first one is just you can flip any particular value within the string from 0 1 or 1 to 0. And then the other one is you can move elements from the start to the end. So you can move like the first character to make it become the last character. And there's some examples here. So like here, you can make this 1 into a 0, this 0 into a 1, and it becomes alternating starting with 0, 1, 0. And then this story alternating, then this one, you make this 1 into a 0. So when I did the work last night, the kind of straightforward stuff would be just converting the string into integer array. Just yeah, just make it easier to kind of parse and do some logic on it. And also doing a comparison of the number of operations needed to perform, the number of type 2 operations, just flipping operations needed to perform it to make it into a 0 1 binary array of 0 1 0 1. And I use some kind of maybe unclear logic, but this basically does that. For every index within the integer array, compare the index to basically 0 or 1 alternating, because mod 2 makes it remainder of that. Remainder of 0 is 0, remainder of 1 is 1, remainder of evens is 0, remainder of odd is 1. So it's basically comparing that, and then XOR with the actual value in the string or array, and keeping track of that number. If it's 1, that means that it needs to change, and then keeping track of the number of changes, the number of flips that you need to do up to a certain limit. So flips is basically number of kind of type 2 operations needed to make array into 0 1 up to a certain index for every index. So the other thing is if you try to calculate the number of operations, the number of flips needed to convert to 0 1, or the number of flips needed to convert to 1 0, they're complementary. They would sum up to the number of elements in the array n. So so your answer can start off with either like doing no type 1 operations, flipping to 0 1 0 1, or flipping to 1 0. So that's your kind of initial starting answer. This is not including the type 1 kind of operation. And technically, if it's an even length string, like in the first example, you can do some kind of simple test cases on that. Anytime you try to like move the first character to the last character, doing the type 1 operation doesn't actually improve at all the number of flips that you can do, the minimum number of flips to make it alternating. So therefore, if it's an even number, like it just doesn't matter in terms of like actually performing a type 1 operation. So therefore, if it's even, the length of the string is even, I'm just going to return that kind of first starting answer. The difficulty then is just trying to handle the odd length strings. And for the odd length strings, obviously it's going to start with a certain letter, like, or certain bit, like 0, and it'll end with the same bit. Like, obviously that's how odd That's how an odd binary string would work, right? Odd alternating binary string. Or it starts with a 1 and ends with a 1. So what I'm going to do here is I'm going to cover, well, one basic facet is anytime you need to perform a type 1 operation, it's it doesn't benefit at all to do non-contiguous kind of substrings of the string to do the type 1 operation. So you do the type 1 operation on a contiguous portion of the string, and then that's it. There's no way that somehow it works out better that you do like type 1 operation in, let's say, index 0 and then index 3 somehow. It doesn't work. So yeah. So I'm thinking of basically for every index up to that index, I'm going to consider that the pre, and after the index, I'm going to consider the post array, and I'm going to make the pre move to the back to become the suffix of the array using the type 1 operation, and I'm going to consider how many operations there would be to form the overall string or overall binary value binary array to be alternating in that case. So breaking it down further, the pre can start with a 0 at that index, so that's just flips at I. Again, flips gives me the array of necessary flip operations up to a certain index to make it start at, to make it an alternating binary array starting with 0. So flips I will get me that. So if I were to have a string that starts with 0 and that's going to be moved to the back, in order for that to be alternating, then the post string needs to end with a 1. So if it ends with a 1 and currently flips compares it to a string that starts with 0, a string that starts with 0 will end with 0. So I need to find the complementary value for the number of flips to convert the post string to end with a 1. So I take the length of the number of values in the post string, so that's similar to n in kind of the general case, and I subtract the number of operations to convert it to a 0, because that would make it the complementary number of operations to make it into end with a 1. So that's combining basically a 0 and a 1, or combining a 0 at the start of this pre-1 and a 1 at the end of this post-1 to be an alternating binary string. The alternative is if the pre starts with a 1, and again, that's the complementary number of operations for the start, for converting the start from a 0 to an alternating starting with 0. So the length of the start is I plus 1 minus the number of flips to get to start with 0 is now going to be the number of flips to start with 1. And then I would need to attach that to a string that ends with 0. And the string that ends with 0 is just the number of operations between flipping at the last versus flipping at I. And then those are the two kind of conversions to make this index be the breakpoint between the pre and the post strings. And then I find the minimum between the current answer, converting it to like something that attaches at a 1, 0 here and attaches at a 0, 1 here. 0 being kind of the last of the post, the first of the pre. And then I do that for every single index and then return an answer. And then the runtime was decent. Yeah. So go ahead and write the summary for this. Oh, this was the test case that I was using to debug some of this. I'm not sure if it makes that much sense, but I'll just keep it anyways. This was me going over the test case for, I think this was example 2, example 1, the number of flips to make it 0, 1 versus 1, 0 alternating. And then it just ends up being 6 in sum. And so it's basically showing that even numbers, even length strings, so we'll have a complementary number for type 2 operations. All right, so summary. Just do general points here. One, for ease, this is kind of optional. For ease, convert string to binary array of integers, 1s and 0s. 2, create flip array, where flip I is the number of flip, which is the type 2 operation needed to convert up to ith index. The array to be alternating, starting with 0. So for instance, flip it, let's say 10 equals 4. Means, I think it was plural actually. Flips at 10 equals 4 means for type 4 operations needed, or type 2 operations needed to convert to, if it's 10, then it's going to be 5 sets of 0, 1s, 0, 1, something like that. And then 3 is for even length strings. Doing type 1 operations cannot improve minim. Thus return flips at n, or flips return the minimum of flips at the last. So flips at n minus 1 versus n minus flips at n minus 1. Because this is the number of ways the number of operations convert to 0, 1, 0, 1 alternating, versus this is number of operations converted to 1, 0, 1, 0. This is with the understanding that for any string or substring, the total number of flips to convert to 0, 1, 0, 1 alternating versus 1, 0, 1, 0 alternating is complementary, i.e. flips to get 0, 1, n will add to n. So for example, if you have a string that is, let's say it takes 2 flips to get 0, 1, 0, 1, or 1, 0, 1, 0, 1, 0, versus 4 flips to get 0, 1, 0, 1. All right, and then part 4 would be for odd length strings. Decompose the problem to, well, for odd length strings, consider the index where you will split string to pre and post, where pre will be moved via type 1 operation to post to after post. So i.e. if the string is something like AB and pre equals A, post equals B, then we're considering it consider after type 1 operation BA. So in that case, decompose it further, consider operations to get A to start with 0 and B to consider number of flip operations, and B to end with 1, such that actually A to start with like 1, 0 repeating, right? And B to end with 0, 1, so dot dot 0, 1, 0, 1, such that after the movement, the connection will form an alternation, right? If you move something that starts with 0 to the back, attach it to something that ends with 1, then that'll make it a 0, 1. So use the flips array appropriately to calculate each of those components really carefully, to calculate how many flips it takes to get A to become 0, 1, 0, 1, and B to get to end with 0, 1, 0, 1, end with a 1 rather than a 0. And then that's one possibility. The other possibility is A starts with 1, 0, 1, 0, dot, 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 and B ends with, B being the post, ends with 0. I guess it'd be dot, 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 0, 1, 0. Update answer if either is lower. Minimum of all those kind of operations, or all those sums. So yeah, it's this code is very, very tricky, I'd say. The indexing is very important there. I kind of screwed up with n versus n minus 1 in some of these things, or maybe I minus I versus I plus 1 here, but it needs to be correct, very correct. Alright, time complexity, this can be O of n, where n is the length of the string. You need to iterate over every index, doing constant work. Yeah, there's at least one iteration to do the conversion to a list, finding the number of flips, and then the iteration to determine the best index I. Space complexity, this can be O of n. To have the list of integers and also have the flips array.